this channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your physics class 11, that is your class 46. And now we're gonna start discussing about it, where we had completed your 45 classes of the session. In unit class 46 here, which is your unit 5, that is laws of motion, will continue. And in the last classes we had done the numerical on the cyclist speeding. You can go ahead and you will figure it out. Thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Let's go for it. And the 11th question of the session. So here the question is, a circular racetrack of radius 300 meter is banked at an angle of 15 degrees if the coefficient of friction between the wheels of a race car and the road is 0.2. What is the optimum speed of the race car to avoid wear and tear on its tires? And the second is the maximum permissible speed to avoid slipping. So let's go for the same. A circular racetrack of radius 300 meter is banked at an angle of 15 degrees if the coefficient of friction between the wheels of the race car and the road is 0.2. What is the first is optimum speed of the race car to avoid wear and tear on its tires, and maximum permissible speed to avoid slipping. Now we go for the solution here, and that is being as follows. Let's go for the solution. So on a banked road, the horizontal component of the normal force and the frictional force contribute to provide centripetal force to keep the car moving on a circular turn without slipping at an optimum speed. The normal reactions component is enough to provide the needed centripetal force, and the friction force is not needed. The optimum speed VO is being given here. VO equals to RG tan theta half. So we have R equals to 300 meter, theta equals to 15 degree, G equals to 9.8 meter secant inverse square. So we have V naught equals to 28.1 meter secant inverse. The maximum permissible speed Vmax given by Vmax equals to Rg mu s plus tan theta upon 1 minus mu s tan theta half 38.1 meter second inverse. Now we go for another one, which is the question is you're solving problems in mechanics. That is the question here. So now we go for the detail solving problems in mechanics. Here are the 3 laws of motion that you have learned in this chapter. That are the foundations of the mechanics. You should be able to handle a large variety of people in mechanics, and a typical people problems of mechanics usually does not merely involve a single body under the action of given forces. More often we will need to consider as assembly of different bodies exerting forces on each other. Beside each body in the assembly experiences the force of gravity. When trying to solve the problem of this type, it is useful to remember the fact that we can choose any part of the assembly and apply the law of motion to that part of provided we include all forces on the chosen part due to the remaining part of the assembly, and we may call the chosen part of the assembly as the system and the remaining part of the assembly plus any other agencies of forces as the environment. We have followed the same method in a solved example, and to handle a typical problem in mechanics systematically, one should use the following steps. So the first step, you have to draw the diagram showing systematic the various parts of the assembly of the bodies, that links, supports, etc. Second is you have to choose the convenient part of the assembly as one system. The third is to draw a separate diagram which shows the systems and the forces on the system by the remaining part of the assembly, including the forces on the system by other agencies do not include the forces on the environment by the system. And a diagram of this type is known as a free body diagram. Note this does not imply that the system under the consideration is without a net force. In a free body diagram include information about the forces, their magnitude and the directions that are either given and you are sure of. Example, that the directions of tensions in the string along its length. The rest should be treated as unknowns to be determined using laws of motion. If necessary, for the same procedure of the another choices of the system. In doing so, employ Newton's third law, that is, it is in the free body diagram of A, where the force of A due to the B is shown as F, and then in the free body diagram of B, the forces of B due to A is shown by the minus F. The following examples illustrated the above procedure that we'll solve here. So the question is, I just go ahead and I just write it down for you so that it will be helpful for you as well. And then after that, action reaction pairs will discuss about it. So the question is a block of mass 2 kg rests on a soft horizontal floor when an iron cylinder of mass 25 kg is placed on the top of the block. The floor yields steadily and block and the cylinder together go down with an acceleration of 0.1 meter second inverse square. What is the action of the block on the floor? First is before and after the floor yield. Take G equals to 10 meter second inverse square and identify the action reaction pairs in the problem. So that what we have to discuss. Let's go for it. wooden block of mass 2 kg rests on a soft horizontal floor when an iron cylinder of mass 25 kg is placed on the top of the block. The floor yields steadily and the block yield steadily and the block and the cylinder together go down with an acceleration of 0.1 meter. What is the action of the block? On the floor. The first is before, the second is after the floor yield. G equals to 10 meter second inverse square. Identify the action reaction pairs in the problem. Okay, so we'll go for it, and here on the same way with the discussion about in the detail, the block is at rest on the floor. It's after it is its free body diagram shows that the force on the block and the force of the gravitational attraction by the earth equals to 2 into 10 to the power 10, that is 20 Newton, 2 into 10, and the normal force R on the floor on the block by the first law. The net force on the block must be 0, and that is R equals to 20 Newton. Using third law of action of the block, that is the force exerted on the floor by the block is equals to 20 Newton and directed vertically downward. The second case they had said about it, which is your the after, and so after the floor yield, it is that the system block plus cylinder that accelerate downward with 0.1 meter second inverse square, with a free body diagram of the system that shows two forces of the system and the force of gravity due to the earth 270 Newton and the normal force R dash by the floor. So note that the free body diagram of that system does not show the internal force between the block and the cylinder. Applying the second law to the system, it will be, we have, So on the same way, it will be your 270 minus r dash equals to 270 into 0.1 Newton, that is r dash is equals to 267.3 Newton that we have. On the same way, if I'm going ahead in the detail, where we have a figure for free body diagram of the block. So this is a surface where there is an object. So here 20 Newton. So this is free body diagram of the block. Now free body of the diagram of the block plus lambda, it will be a dash, and that is down. Down it is 270 Newton. 270 Newton. So by the third law, the action of the system of the floor is equals to 267.3 Newton vertically downward. Now we discuss the another topic, that is your action, a reaction pair, and that is of course being important one. So let's go for it. So that we'll discuss in the next coming class, which is being will cover up and ended up in the last class. So here we're gonna end up with thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. So stay tuned with us, and please keep supporting us as you had supported till the day. Thank you.